All right, chapter 6. So we spent one chapter going over integrals. And integral was just trying to find the area under the curve between the curve and the x-axis, pretty much. Now we have two curves, f of x and g of x. We want to figure out what is the area in between them. Okay, talk to your partner. What's some good ideas of finding the area between these two curves, the green area? Okay, what are some thoughts? How do you find the area between the two curves? I heard some correct answers. Any thoughts? Yes. How about Austin and Sarah? Okay, f of x minus g of x, and then find the area in between. Any other thoughts? That is an official answer. Very good. Okay, so how would you find the area in between? Well, all you do is, first find the area underneath f, which is this big part, right? Minus the area underneath g, which is this big part. And then that would give you the area in between. Okay, so that is the official answer. Okay, so the area between A to B, what you want to do is, okay, first of all, if F and G are continuous, bless you. Continuity is a very important part of calculus, right? We always want to check to see if it's continuous or not, and to check continuity, got to go back all the way back to chapter 2. Okay, so if f and g are continuous and f is bigger than g, meaning that f is higher than g for all x in A to B, then the area from A to B, the green area, is going to be f of x minus g of x dx. Hello. Okay, so the area, the green area, A, is going to be the integral from A to B of f of x minus g of x. And again, in this case, you're taking f minus g because f is the higher curve. And then g is the lower curve. Whoops. Okay, of course, area or integral came from Riemann sum, right? We were taking like little slices of rectangle and we add them up. So I'm not really going to go through the proof of Riemann sum, but just know that basically all the integrals come from Riemann sum, which is, we make tons of little rectangles and then we add them up. And then eventually the limit goes to infinity, and then so that becomes a smooth curve, and that's how you get this. But we're just not going to go through that part. Okay, now let's go ahead and solve a problem. The problems are going to be pretty tricky. You have to know your parent function, because if you don't, you will not know how the shape looks like, and they will try to trick you with figuring out which one is the higher one. So you have to, in your mind, know how the functions should look like even without your graphing calculator. Okay, find the area of the region bounded by y equals e to the x below by the graph. Oh, they're very nice. They tell you that above is e to the x, below is y equals x, and between the lines x equals 0 and x equals 1. Okay, so let's go ahead and draw out what that looks like. So you're going to draw e to the x and y equals x. Okay, I don't always draw the correct graph either. I'm just drawing what I think it should look like, and then if it doesn't, we're going to check algebraically to see if it's true, so then we can always change it later. Okay, y equals x. I'm glad everybody knows how it looks like. Y equals x, and then e to the x is this one. Just I don't really know where they connect yet, but it's okay. Doesn't really matter. Huh? Well, thank you. Okay, well, Chris corrected me. Looks like this instead.
No, they are. Is there supposed to be an error between the two curves?
Okay, now what we want to do is draw two more lines. X equals 0 and x equals 1. That's where the two bounds are, A and B, and then we're going to find the area in between those two. So x equals 0 and x equals 1. Okay, go ahead and shade where you think we want to find the area. So that's also a very important part because sometimes we shade the wrong place and then the whole integral is wrong. Okay, shade where you think we need to find the integral. What area do we want to find? Okay, so also another thing I need to remind you, or just to let you know, this chapter is all, well, not this chapter, first a few sections is about area between the curves. The area between the curves we're finding is all positive, okay? The area between the curve is all positive because we just want to figure out what the area is. Even if it goes underneath the x-axis, we're still going to count it as positive. We just want to know how big that area is, okay? All right, so hopefully you shaded this area. This is what we want to find. Okay, so what is the higher curve? Which one is the higher one? E to the x. And then the lower one is x. Okay, so we are going to find the integral of e to the x minus x dx. Okay, the higher one is e to the x. In that presence of an area, the higher one is e to the x, the lower one is e to the x. From which x to which x? 0 to 1. All right, this is also a very tricky part. This will confuse somebody later. Take a look at this. E to the x minus x. What does this part say? dx, right? It says dx. Therefore, this integral has to integrate on x. Because later on, we're going to integrate on y. It's going to say e dy. And then we're going to go this way, up and down. Right now, we're going in the x direction because we're integrating on x. Later on, we're going to integrate on y. So then this is going to change. So be careful knowing where your limit is. So you can write the correct integral. Okay, so let's have you integrate that. That should be pretty easy. Okay. I think you guys should be okay with this integral. So this is going to be like this, integrated from 0 to 1. So the answer is e minus 3/2. Okay? All right. Practice. Did I write it wrong?
No.
It's correct. E to the 0 is 1. Okay, find the area of the region enclosed by cube root x and 1 over x between 1 and 8. All right, cube root x. Cube root x, I don't have it on here. Cube root x, like this. So flip this x cubed over. So like, looks like this. 1 over x, okay, between 1 and 8. So really the thing is you have to figure out which one's on the top. Okay, all right, so first of all, draw something, right? And then we can always check it later. So cube root of x looks like this. And then 1 over x looks like this. I just don't know if we are in here or in here, right? You can see the two areas, the position of the curve will be different, right? Yes?
Yes.
One person said yes. Okay, not good enough. In this region on the left, you can see that 1 over x is higher than cube root x. The region on the right, you can see cube root x is bigger, higher than 1 over x. So it depends on where you are. Right? If you're on the right-hand side, you're going to integrate differently. If you're on the left-hand side, you're going to integrate differently. The worst thing that happens is you're in between. Like you cover both. Then later on, we're going to do that. We're going to have to split. So then we can write 2 integrals. All right, so how do you know where you are? It depends what the question asks. This one says from 1 to 8, so it's very specific. So what you could do is just figure out where 1 is. So then let's call this first curve this second curve. So y1 of 1 is cube root of 1, which is 1. So 1, 1 is the point where that curve is. And then y2 of 1 is 1 over 1, which is 1. So we know that it's starting at this point, 1. Okay, and then let's check the second one. y1 of 8, cube root of 8, which is 2. And then y1 of 8, I'm sorry, y2 of 8, it's 1 over 8. So that's a very small number. So at 8, we know that the red curve is much lower than the blue curve. So then this is the area we want. And we can be sure that it is not a place where they cross over. Are you guys with me? One person nodded his head, or 2. Okay. All right, we're mostly not getting it. Okay, that's okay. Let's do a few more practices after this, and then we'll kind of check which curve is higher. Okay, so go ahead and figure out the integral. Let me know when you're done. Okay, let's make sure that you first have the correct limits. Oops. Okay, so we are going to integrate from 1 to 8, and the curve that is higher is the cube root x minus 1 over x dx. Okay, integrating that, we get 3/4 x to the 4/3 minus natural log x. And we're evaluating from 1 to 8. So your answer is 45 over 4 minus natural log 8. All right, let's try a trickier one. Find the area of the region bounded by the parabolas y equals x squared and 2x minus x squared. Draw those two graphs. Okay, x squared is easy to draw. This one. X minus x squared, what are you going to do?
Put in random numbers.
Ooh, yes, you could. Or complete the square. So, yeah, you're going to have to complete the square later on anyways. You do need it for this class. So you're going to complete the square to figure out where the vertex is, and so you can look at the transformation and all that stuff. All right, if you don't remember complete the square, let me know. I will help you. Okay, first, draw the first parabola, which is easy. Y equals x, right? You can do that. Okay, the second one. Y equals 2x minus x squared. So we don't know how that parabola looks like. We're going to complete the square. So we're going to switch the order. Nobody remembers how to complete a square. Okay, take out the leading coefficient, which is -1. Add a magic number. On the same side, you would subtract it out, but the leading coefficient is a negative, so we're going to add a magic number. The question is, what is the magic number? 1. B over 2 squared. Are you guys okay? Still remember? Okay, so 1. So this is going to be negative x minus 1 squared plus 1. Okay, can you graph that? I hope so.
What's the negative? Like, what's the negative will look like in the graph?
Oh, go down.
Okay.
Okay, so draw what you think the graph looks like. That way you can see where they intersect. So you can see the vertex is going to be at 1, 1. And then the parabola is going to point down. So something like that. I don't really exactly know if it is that, but right now we know that they're probably going to intersect like that. Okay, so this is the region that we want to find. The question is, what are those 2 points that they intersect? Okay, talk to your partner. How do you figure out where they intersect? Algebra 2. Don't talk to me. Talk to your partner. Algebra 2. How do you figure out where 2 curves intersect?
Of course, you can always just whatever you want to cover that's where they intersect. Take it hard.
All right, where do they intersect? How do you know, how can you figure out where they intersect? Yes. No. Okay, so algebra 2, we said, how do we figure out when 2 system of equation intersect? Equal. Okay, set them equal to each other. Make them equal to each other. Okay, x squared is equal to 2x minus 2. Equal means that they are at the same place, right? So that has to be where they intersect. Okay, so how do we solve? Okay, this is totally algebra 2 review. Huh? Add x squared. So 2x squared equals 2x.
Divide by 2.
Okay, divide by 2.
X. 2x.
Huh?
Divide by x.
Hmm? Oh, divide by 2x. Oh, no, that is the bad idea. We never want to divide anything that has a variable inside because we'll lose the information. Okay, what should we do when we solve something? Very good. Good job. Okay. You deserve that A you earned. Okay, so now what? So long ago, 2-3 years ago. Take out an x. Factor. Okay, and then x equals 0, x equals 1. Okay, so we know that it's going to intersect at 0 and 1, so my graph is incorrect. It needs to move over a little bit. And they intersect at the highest point. But it's okay. So we are going to integrate from 0 to 1. The higher curve is the downwards curve, which is 2x minus x squared. And then the lower one is x squared. All right, go ahead and figure out the answer. All right, the answer is 1/3. Okay, give me a thumbs up if you got 1/3. Ooh, people over here, give me a thumbs up if you got 1/3. No. Okay, all right. Okay, let's see. Do I have another problem? No. Okay, I'm going to show you how to do this on a calculator because tomorrow it's all calculator and the calculator gets kind of crazy, but I found some shortcuts on the calculator I'm very excited to show you. On the TI-84 Plus. The Inspire, I don't know how to use. Or if you have 89, I don't know how to use it either. Sorry about that. Okay, we are going to figure this one out with our calculator. So you're going to first type both equations in the graphing part. That way we can just use it later. Okay? So you are going to type in y1 as x squared and y2 is 2x minus x squared. Okay, now you're going to graph it and see where they intersect. And looks just like the way we predicted. Okay, so the next thing you're going to do is ask, this is easy because you can actually solve it. But later on, you're going to find graphs where the intersection is not clear. You're going to have to use your calculator to figure out the intersection. So to figure out the intersection, this one has 2 points where they intersect. You're going to go to second calc or trace. And then on top it says calc. And then go to intersect, which is number 5. There are 2 different intersecting points, so you're going to have to do this twice. The first one is easy. It's just 0, 0, so you can skip it if you want. It's going to ask you first curve. Just press enter, and then it's going to go to second curve. So it's on the top, it says y1. And when you press enter, it goes to second curve. And then on the top, it says y2. So then they're trying to ask you which two curves do you want me to figure out the intersection of? Okay? All right, and then press enter. And then it's going to say guess. Okay, so this is the crucial part. You have 2 intersecting points. So you're going to have to do this twice. Once near the first intersecting point, second time near the second intersecting point. Does that make sense? Okay, so the first time you do it, you're going to tell them it's about here. The second time you do it, you're going to tell them it's around here. That way they will give you 2 different numbers. Okay? All right. So now let's say that you already figure out what those 2 are, and you're going to calculate the integral. Okay, I'm going to show you how to do this with your calculator. So you know that it's going to be the downwards parabola minus the upwards parabola. So you are going to go to integral. Okay, you know where integral is. Okay, go to integral. You're going to put in 0 to 1. Okay, this is the crazy part. The 2x minus x squared is the second curve. That is y2. So then this time, you don't have to re-type in the whole thing. Just type in y2. The question is, how do you find y2? You're going to do y2 minus y1 and then dx. Okay, to get to y2, okay, they showed me this yesterday. You go to alpha y equals. Alpha is a button on your calculator.
Maybe you can just use the VARS.
Yes, but this one's faster. Yeah. So that's going to bring up a sub-menu. And then you're going to go to the one that says YVAR, which is on top of the trace button. Huh? And then you just choose Y2. You have the old one. I don't think it's
Can we just use like alpha trace?
Yeah, I don't think but you can go to YVARS. This always works. The newer one has an additional menu. Okay, second, alpha, and then YVARS. Alpha, this one. Click on it. Yeah, trace goes to YVA on that's right, and then choose. Yeah, and then minus this one. And then dx, that's going to give you 1/3. Yeah. Oh, didn't work? Okay. Okay, so tomorrow we're going to do really hard integrals on the calculator, and some of them are going to have like really strange fractions. And then so someone showed me yesterday how to type in fractions on your calculator without all those parentheses. So it is the same thing. So you're going to go to alpha. You can try it today just to see how it looks like. Alpha y equals 2. Okay, and then right on top where it says, like the menu kind of looks like this. It says 1 n over d, 2 u n over d, and then 3 something like this, n over d, and then, something like that. Anyways, n over d just means numerator over denominator. So if you choose this first one, it looks like a fraction. Like it would just give you this fraction. And then so you can just type it in as a fraction instead of like a bunch of parentheses kind of stuff. Okay, so just a little shortcut. So later on, what you should do is whatever function they want you to do, always just type it into the graphing part first. That way you only type it in once, and then you can keep using it for the rest of the problem. Okay. Are you guys good for now? Okay, I'm gonna just let you start on homework instead of giving you another problem.